couple of years ago I made a video showing my unusual custom all plastic XY joints and an actual printed beam that's part of the same part there, and it also has two X rails. At the time I was really pleased with the result, and it really helped the tool head rigidity. You couldn't really move it much at all. Now, a couple of years later, for some reason, we're going to find out why, the tool head is actually really mobile. It looks worse in real life. And I think a large part of the problem is that the printed plastic beams, although they were really rigid in the first place, have just weakened and become more flexible over time. They are just printed in regular ABS. What I've done is reprinted those parts in Soraya Tech ABS carbon fiber core is the version I've used. Reprinted the two custom XY beams and the special X carriage to fit on two rails, and a couple of other related bits to make them really rigid. I've done 100% infill as well, and they've come out really nicely. Also, I'm now using the standard Voron bearings in there rather than, I tried bigger ones to try and eliminate some VFAs or vertical artifacts. I thought using bigger ones would mean that the belt teeth would sort of catch on them less, but that didn't actually have an effect. So I switched back to these ones. So today I'm going to be pulling the printer apart to replace those, and at the same time, because pulling the printer apart is a big job, I'm going to do a couple of other things at the same time. First, I'm going to show you the custom toolboard that I made. You'll see it better after I've pulled it apart. This is a special toolboard I made just for the Voron Zero, which connects to everything, and yeah, you'll see it more in a second. Also, I'm going to be showing ADXL probing, so you can actually probe with your nozzle using just an ADXL accelerometer like a lot of people are using these days. This is the toolboard, of course, includes one of those, so no more need to wire one in. And I'm also going to be swapping the belts and idlers for some nice new 1.5mm ones, or 1.5 GT as I think they're called, which supposedly will have an effect on reducing the VFAs. First of all, let's have a look at ADXL probing. So most people don't know this, and I didn't until really recently, but you can use the accelerometer to detect when the nozzle has hit the tool bed. This is an extension or an add-on for Klipper, which I've heavily modified and added to this code base. I forked a fork basically on GitHub. This is my repository here, which is forked from the one by Link's crew, which was in turn forked by the one by, sorry, I'm not sure how to pronounce this, and I've added a whole lot of features to make it work a whole lot better. So let's have a look at it in action. Also, using the ADXL probe, it can do sensorless homing of the X and Y axes without the need to do that with the diagnostic pin on the motor drivers, or let alone with end-stop switches. And there you could see it homing on the Z as well as the nozzle hits the bed. Let's do a probe accuracy test. 50 samples. It's only having to move a couple of millimeters for each one, and it's actually moving the bed at, I think it's at 28 millimeters per second, which is pretty fast for a Y-axis, and it's kind of unbelievable it can move it that fast and still capture the level of accuracy that it does. And here are the results. Standard deviation of just 3.18 microns. Absolutely tiny. 0.003 of a millimeter, and range of 19.2 microns. Probing is finicky. If there's any filament oozing out of your nozzle, even if you have the print head at a temperature where that should just melt, it can fail to trigger. And you'll be saying crap, crap, crap as you try to move the print bed away from the tool head. And this is a huge inconvenience. It's one that I'm happy to put up with because the bed probing is just so useful. but you sort of have to heat the nozzle up for PLA. I heat it to 140 degrees, at which the filament is just a tiny bit soft, so I can scratch it off the nozzle just with my finger. Then I home it, and only then do I increase the temperature to 200 or whatever degrees and actually do my print. Let's have a look at doing a bed mesh as well. So I think this is amazing. Hopefully some more people will try this in the future, although I will say it's very hard to fine-tune. I have got it working pretty much perfectly, but even using the add-on for GitHub, the add-on for Klipper, you have to exactly fine-tune the speed that you want the bed to move at, or the z-axis to move at, as it does those little taps. You also have to fine-tune the sensitivity, and here you'll see the resulting bed mesh for a Voron 0. It's very unusual for anyone to have the ability to probe on such a printer. Now what you might notice is that it's a pretty crap bed mesh. The range is 0.133 millimeters, which really is much more than you'd expect for a tiny bed like that. Ignore the fact that my x-axis is so reduced. That's due to something silly I did, which is going to be undone by the mods we'll be doing today. When I was able to do a wider bed mesh, it really sloped down a lot over here. So it's really unacceptable. And my suspicion is that a big part of the reason for that is really problems with the motion system rather than the bed. I held a ruler on the bed and it didn't seem to be unflat at all. As the tool head comes forward here, this is a problem with a lot of 3D printers really, the incoming filament and potentially wires as well will sort of pull the tool head back a bit compared to at the back here where it will sort of squish forwards more likely. So today, again, I'll be replacing those XY joints and we'll compare bed meshes afterwards and see if it does fix it up. Our first print is just a basic sphere to try and accentuate salmon skinning, which is generally a problem in 3D printing that was solved a long time ago with the TMC motor drivers. But actually, even with those, if you look really, really closely on a sphere print like this, if you look really closely at the bottom left there, you'll see a tiny, tiny bit of salmon skinning. I believe that is due to the steps of the motor driver. I've experimented with the options for interpolation and stealth chop and also the number of micro steps. That's never seemed to have an effect on this issue. And for our second print, we'll be doing Orca Slice's VFA test where the print head will move at different speeds, and we'll just see what comes up. Here we go, it's printing those first layers good and slow, and it'll gradually speed up, and we'll see how it looks at different speeds. So that's really interesting. I haven't run this exact test before. I had just run sort of cubes at different speeds. This is great because it does different speeds at different heights. I took some measurements and crunched some numbers. The x-axis, which we see here, gets bad above around 30 millimeters per second. That's that big transition you see there. The y-axis gets bad a little bit higher, around 48. And then diagonal is really good. I already sort of knew that printing on the diagonal axis was better on this printer, and yeah, depending how you look at it, it never really gets that sort of liney look. This is only just one of the diagonal directions, 45-degree directions. The Orca Slicer model doesn't do the other one. I'd have to flip it. And now the fun part, or the not so fun part, depending how you look at it. It's time to pull the printer apart. First, now that I've got it open, I'll show you the toolhead board that I designed. The design's on GitHub. Unfortunately, it's quite hard to assemble. I've done this unusual thing. So it takes a USB cable, USB-C, and it has to sit on its own extra little circuit board there so that the cable can sort of fit there, and there's a strain relief at the top on the circuit board that it can get attached to with cable ties. The USB cable gets 24 volts. This is completely non-standard down here. I don't have a Raspberry Pi in the printer. I use it with a separate Intel NUC mini PC. This is a USB hub here, which connects to the control board, and also through this tiny little circuit board here, which takes USB from this hub into here, replaces the 5 volts with 24 volts that we feed in, then goes to the USB-C cord, which goes all the way back up to the tool head. That's completely non-standard and dangerous. Don't do that at home unless you want to really experiment. And the tool head comes off just like that, just by removing one USB cable and undoing some screws. So that's all done now. The new parts are all on. I have to say it's not quite as sturdy as I thought it would be. I feel like last time it was more sturdy than this, and that was just using ABS parts with only about 50% infill. It's a wee bit floppy. It's not too bad. I think possibly the problem might be the rails, which got incredibly rusty. I'm sorry everyone. I've now cleaned them and re-lubricated them, but still brown rust sort of gunk just keeps on sort of bleeding out of it. So I think actually next time I pull this apart I might just get 2 new rails for my X-axis. You'll also see that I've got these nice new 1.5mm belts on here. The other thing I've done is I've replaced the pulleys, of course, for the motors with 1.5mm ones. Sorry, you can't see them anymore, really. But I also opted for ones with a smaller diameter, with about the same number of teeth as the bigger ones that I had on there, standard ones. Same number of teeth, smaller pitch, so the whole the diameter is smaller. That should mean that each step, well, it will mean that each step of the motor corresponds to less movement of the tool head, and that this should mean there's less scope for the steps of the motor to contribute to VFAs. Now I could have also switched to 0.9 degree motors, as I've seen talked about elsewhere. That would further, I think, alleviate that problem. I wanted to just try changing the belts first to see what difference that makes. So I've modified the rotation distance for the X and Y motors to 31.5, which is the correct amount for the 1.5mm belts with the small 21 tooth pulleys. And now the moment of truth, doing our bed mesh. Will it look significantly different or better to what it was before I reattached with the carbon fiber XY joints and flipped the rails? I put the top rail where the bottom rail was, the X rails that is, and vice versa, to see if any of that bend was due to the rails and will now end up sort of upside down from what it was. Okay, that's not a great looking bed mesh, obviously. I suppose I should tilt the bed over to the right a bit more, and we'll see if the flatness then looks any better than before. Still not good. Let's try doing that again. So this is probably about as good as I'm going to get it. Range is still about 0.16, which you can actually see is pretty much the same as before I did all these modifications. So perhaps it was all for nothing. Let's just try one last thing. Removing the Bowden or reverse Bowden tube and the filament from there, just in case that was sort of pulling the tool head up. Okay, as I expected, not really any difference. So it's still a bit of a mystery. As you can see, the bed is not warped up in the middle at all. So that 1.6 or so millimeter, no, 0.16 millimeters in the middle isn't due to an actual physical warping of the bed. I've also tried a few different magnetic PEI sheets, because I have a few. So I'd be really curious to see if anyone else has some sort of probe in their Voron 0, whether you're getting the same sort of curving, same sort of unflatness of the bed. I suppose another idea, this might be the obvious one, perhaps I should have stuck with an aluminium X-beam rather than my fancy plastic printed one. But I do think that with the aluminium X beam and only being able to have one X rail, that really made the tool head pretty pretty. It was wanting to sort of rock backwards and forwards and up and down a lot. And I do think that with the cable going to it and the filament with its reverse Bowden tube going to it, that did seem to, when the print head sort of got to the front here, it would tilt back quite a bit. So I don't know that that's really a very good solution. I should also add that with the bed mesh that I get, at least last time I tested it, which was before I changed all of this, but I'm sure it's the same, it does in fact help get a much better first layer than if I was not doing bed meshing at all, which was really struggling. So printing that sphere again now to check the VFAs and whether the smaller pulleys and 1.5mm belt has made a difference. Unfortunately, that didn't really help all that much. Can you see in the bottom left corner there that little bit of salmon skinning still? And now reprinting the VFA test at different speeds. And did swapping the belts and pulleys to 1.5mm help with the VFAs at different speeds? Comparison. This is the old X-axis. This is one of the worst ones that we'll see. And new X-axis doesn't look so bad with the 1.5mm belt. Old Y-axis. This is actually not that good, is it? New Y-axis. About the same, maybe a tiny bit better. Old diagonal. New diagonal.